Okay, this is the session. G's carefully put together a nice note well. Please read them. Anyone not ever read a note well? Okay, I can't see the online, but please, by participating, you are agreeing to the ITS process and policies as a professional organization, and that involves the patent. So please read this in detail. With so many people having been here a long time, I will stop at that point. Okay, we're going to go on to the agenda for today is a status. We skipped the status on Monday, so I will be giving the status. Then Ajon is giving the update on VPN prefix outbound route filter. Looks like we've got two implementations, so please pay attention to this as we may be heading toward working group last call. We have a Yang model for RPKI presentation. This was done in CyberOps, but it's going to be interesting to you as you need to think about whether that's a useful protocol. We have a BGP extensions for 5G. There's been some update. By the way, there is a GitHub repository on this should you want to issue comments, and you'll see that it will echo to the authors. And then lastly, we have Luja, did I pronounce it good, correctly, is giving her ITF debut on a set of packet content filter for FOSPEC. You may realize this is looking farther into the packet. We've had some stuff in the past, maybe 110. So if you recognize some of the ideas, we're going for that. Okay, on to the status. Oh, I get to even do it here. Cool. We're testing to see if the slide. So this is the document status. As you notice, I about once a month put out document status, and you can find that on the ITF wiki. And this will go through some of our plans for 2024. Do let me know if you want status reports more frequently than once per month, if you'd like it every other week or every week. And I'm looking for any documents that need fast tracking. Okay, what did we complete? Well, kudos to all of the working group. We completed the CAR and CT work. I'm probably a day or so away from sending all of these up to the ISG. They'll be sent as experimental drafts. Then we have the SR policy SAPI and the draft IDR BGP SR segment types extension. That's a really hot, easy name to use, but these will be set as first proposed standard and then experimental. Keaton, did you want to make an additional comment?
Yes, Ketan Talaulikar, Cisco. This is a very small nit about the latest change in the CT draft. It's in the IANA section, and I had dropped a mail to the authors to clarify some parts there. So I would appreciate a response on that. It's just a small nit, but I think it's important.
Which draft was that again, Keaton?
The CT draft.
The CT draft. Dude, that would be good. I will check with.
I will drop another top post and drop another update right after this.
Okay, I will look for that. Thank you for letting me know. Anything else? Okay, we'll go on to the next set of things. Thank you. We have a working group last call pending. That's a send hold timer. I think we'll start it immediately, well, probably a week or so after. I gave, Jeff and I both gave the authors some comments, and we want to allow them time to put it in the draft and the implementations. Go ahead. Now, these are the adoptions I have in order. And as you know, I go through the order and we try to review the documents ahead. I think if you've had a recent document adopted, you realize that the chairs are really putting more time ahead of the pre-adoption, of the adoption call to do a pre-adoption review. So if this is not, if you think you've asked for working group working group adoption call, and it's not on this list, please let me know. I try to keep the list up to date. I've also given you the category that we tend to see your document in. If that's not the right category, please let me know. Other than that, I won't read this so that you have a shorter day. Okay, plans. Well, we finished, we hope shortly, buttoning up the car CT work. We will do a call on CPR, which is uh, an informational document related to car CT, and then we're going to dive into new week work in the upcoming weeks. So the plans are really to get back to the BGP flow specification. We've had people ask for it, and refined documents on BGP functions. I think you've seen the AIG and the ad path. Refine your BGP LS and BGP SR drafts, and we encourage any Yang work. So please let us know if you're ready for working group. Last call if you'd like some additional help.
So one other thing that we're also looking at is the back queue. We have a lot of drafts that have been around for a very long time, deployed. People have been using them for years. We're looking to actually get these things shipped as RFC because, especially as part of things like Yang work, we need stable references for them.
And as part of that, some 20-year-old, and I really do mean 20-year-old documents, have been sitting there as IDR documents, and we're going to start cleaning them out. If you haven't gotten an implementation, probably it's time to move on. So watch the mail list for that. Okay, now into a more focused thing. FlowSpec v2, we wrote a fairly good, and I is the sort of editor for the working group, combined all the FlowSpec next generation work into a FlowSpec v2. What we found out is that's too much for someone to implement in a short amount of time, so we can get lots of implementation. So we are going to go into a different approach. We're going to keep the large working group document there, but try to break off individual pieces and try to see if we can get them into the hands of implementers and have them implement. So to do that, we're going to start out with what I'll call basic IP FlowSpec v2, which is basic our current IPv4 and v6 filters, plus our current actions and order. Order is enough for many implementers to pick up. Then we're going to go from that, and we're going to add more IP filters to look farther in the packet. And you'll hear one discussion on that today. That's important because we know that a lot of people are looking for it. Now, we're going to ship the document in this way, but we're going to start the discussion on all of these points. And I will announce what one will call design teams, but there'll be little interims with very targeted discussion points. And we'll hold them up until the next ITF. Then we're going to do more actions. Actions are, again, something we put into FlowSpec D2, but they're complex. We need a bigger space like wide community to get ordered actions. And we need to define things like what happens if the action fails. You want to drop it and it fails, what do you do then? Or if you want to mark before you drop, that's difficult. And lastly, we're going to look at non-IP. Non-IP is L2, maybe some other layers, and tunnels. So those will all be teams. We'll call them teams where we'll have discussion. If you're interested in FlowSpec in any of these categories, join the discussion group that's announced. If you have questions, send me email. This is a call for input. what we're going to look at is we're going to try to take as many use cases and ideas and shake them down into what we can add to the main draft and how we can form these documents. This is meant to be a fast process because we've just spent 3 years looking at CAR and CT, and we're trying to catch up with the need from the operators. Any questions on this? Okay, well then, Asian, are you doing the presentation today? You're the next presentation, or who is? Please do, you're up. You will need to make sure the mic is close to you.
Do you know how to move the microphone down?
You can.
Okay, thank you. Hi everyone, I'm Wei Wang from China Telecom, and today I will give a brief introduction about the updates on VPN prefix RF for BGP4. And compared to the version 00, we have made the following updates on this draft, and I will introduce them detailed in the following slides. The first update is we define a new extended community, source P extended community. And because we found the next hop value may be changed in some scenarios, and this may cause it not very useful in our solution to identify the source PE. So we hope to find a solution to resolve it. And we define this new extended community to identify the source, and the value of this extended community can be set by the source PER or ASBR, and once it was set and attached with the BGP update message, its value should not be changed along the advertisement path. And when RR or ASBR receive the package, it should first check the existence of the SPEC, and if it exists, the device should not change it. And if it not exist, the device should change the instances of originator ID. If the originator ID is exist, the device should put it into SPEC. And if the originator ID is also does not exist, so the device should put the router ID of the source PE into SPEC to identify the source. And we also refined the processing method of the received RF entry by the receiver. And as this figure shows, the device D will send a lot of VPN routes, and it calls the VPN 1 on device A and VPN 1 and VPN 2 on device B overflowed. So these two devices will trigger the VPN prefix RF mechanism. The device A generate a VPN prefix RF with RD31 and RT1 and send it to device C. And the device B will send two VPN prefix RF entry with RD31 RT1 and RD2 RT1, and it will send this two entry to device C. And because the device C only has two downstream devices, and both of them send the VPN prefix RF entry with RD31 and RT1 to it. So after receiving and check these entries, device C should generate VPN prefix RF with RD31 and RT1 and send it to its upstream device, is the device D. And however, device C should not generate and send the VPN prefix RF with RD2 and RT2 because it only receives this entry from device B. And this update is about the length of the VPN prefix limit because we found we originally set this value to 2 bytes, but the maximum number of prevent network routes it could support is far less than the actual number of routes supported by the network devices. So we changed its length to 4 bytes. And we also have 2 implementations now. One implementation is from H3C, and it realizes the VPN prefix RF mechanism related functions by configuring VRF prefix limit and quota. Achieve the use of RD and source PE to control the VPN routing. And this implementation can generate, transmit, and process the type 1 and type 2 source PE TLV, and it can use the offending VPN routes process method to revoke all routes. And besides, we also have one implementation based on the open source BGP implementation FRR. And this implementation can realize the VPN RF mechanism trigger based on the VRF prefix limit in intradomain and interdomain. And it can also realize the RD-based VPN routing filtering in the interdomain and intradomain. And in this week, we also received the email from INA, and they sent us their concern about the INA consideration. So we update the content of this part, and we also registered the value 66 for the VPN prefix RF. And we hope we can get some feedbacks about these updates, and because we have 2 implementations, so we wonder if we can apply to change this draft to a standard track, or can we consider about the working group last call. Thank you.
We will add your draft to the working group last call. I will send you details about how to do an implementation report, and we'll do a shepherd's check. So yes, it's added to it, and we will work toward that quickly. Thank you.
Thank you, Sue.
Yeah, okay. I should go up.
Hello, everyone. This is Chang Wanlin from H3C. I will prepare my course to present this YARN model. This draft is about YARN models for RPKI routing protocols as defined in RFC 16.8.10, 18.2.10, and IETF as IDR Opus 18 to 10. There are 4 YAM models defined in this draft. RBKI YAM is about how to configure and manage the YAM RBKI routing protocol on routers. BP Orange AS verification YAM is about how BP validate Orange AS or BP routers based on ROA. BP second YAM is about how BP validate BP sec paths of BP routers. BP ASPA YAM is about how BP validate AS paths of BP routers based on ASPA. RBKI YAM models, it contains main paths. The first is a list of cache servers and the global tables for 3 different types which received from all cache servers. For a single cache servers, there are many type nodes. There are 4 type nodes. The first type node is about connectivity parameters, such as the remote server address or remote port of cache servers, and the local IP address and the local ports of local routers. And then the second type node is session parameters. And the third node is about the session state and statics. The last type is 3 type tables, which contain recorders received from that cache server. RBKI YAM, beside the configuration of the cache servers, there are 3 global tables. First, the ROA tables contain IPv4 or IPv6 ROA, and the router key tables contains router key. It is used to validate BGP sec paths. The third global table is ASPA tables. It contains IPv4 and IPv6 ASPA PDOs. It is used to validate BGP AS paths. BP AS verification YAM model. It augments the YAM model of BP with the configuration of Orange AS verification. It is used to control whether Orange AS verification is enabled for IPv4 or IPv6 unicast routing table. Verification state of each router could be checked, and it also adds an option for router selection. When we send the route to neighbor or peer group, it can be controlled whether to attach the BGP extend community, and whether to check the Orange AS validity state of BGP router in export. BPSec YAM augments the YAM models of BP. It is the same with the BP Orange AS YAM model. BP ASPA YAM model augments the YAM models of BP. It is the same with the Orange AS YAM model. In the neighbor and peer tables, we added the peer load for ASPA. Yeah, that's all. Thank you. Any questions, comments are welcome.
Thank you for the presentation. As we discussed earlier, there are people at Juniper Networks that are looking to collaborate on this, so we're looking forward to that. And I suspect that other vendors will too. This is comments mostly about where this document belongs, because there's a couple of interesting questions here that the ADs will care about, and chairs of actually more than one working group. So clearly you're doing many different things in this document. You're providing information for the protocols for like ASPA, origin validation, BHB-SEC, RPKI router. Several of these things, like RPKI router, belongs to the CyberOps group. So clearly they're going to want to take a look at that for all of those pieces. The extensions for ASPA are also being done in CyberOps, but the BHP Yang module you're extending is an IDR. So what we're very likely going to see is a discussion amongst the ADs and the chairs about whether we keep this as you have it today in one single document and just involve all the necessary groups, or maybe split the document into several documents instead. This is not a problem. This is just a process matter.
Yes, we can discuss more in this.
Yeah, and this document is a very good start. For those of you following Yang-related work, I encourage you to take a look.
Yeah, thank you.
Thank you, Johan.
Yeah, thank you.
Thank you for your hard work on the Yang. We appreciate it. Linda, you're next.
Good afternoon. So I'll give a brief update for this 5G metadata pass attribute for 5G edge services. Major changes. So this draft is really to get an early allocation for the metadata pass attribute and give the use cases and some of the TLVs. And we create the GitHub thanks to Sue, thanks to Jeff, and many issues were recorded. And we have one implementation report already sent in. There's an email from ZTE. They have a implementation on this as well. So they actually entered quite a few comments and suggestions on the GitHub as well. This just to emphasize that this is really for special ultra low latency services. It's not for general internet. It's only very small number of prefixes will have their update will have this metadata pass attribute attached. And when they attach, they also attach other pass attributes as well. There are some changes to the, thanks Jeff for the good suggestions. In the original document, we're using 4684 for the ingress routers. No, in this scenario, ingress routers are the one connected to, they are the one actually directly connect to the 5G UPFs. So they actually get the connect to the user device, and they know what kind of services their attached UEs are interested in. So when they are interested in particular services, they can request for the metadata services. So a metadata pass attribute. So those attributes for a particular service is not flooded to everyone. It's only flooded to a few interested parties. So in the draft, we're saying that they are interested in particular addresses. But as the 3GPP's release 19 is coming up, there's more extended services and like they call multimedia, and so they may have bundle of services. So that may create a need for using a kind of a route target to represent a group of services. So we have in the GitHub asking for the working group opinions if we should add a route target instead of just requesting IP addresses. One important thing is the ingress router doesn't flood those pass attributes, metadata pass attribute to other nodes. So when to enforce that, we add in the document that route reflector, when they propagate this update, they have to add non-advertised community to the update so that receiving node will not send it to any other nodes who are not supposed to learn those pass attributes. There's also suggestion from Jeff about this, we call it physical availability index value. So those index value is for prefix to, when they announce the prefix, they basically associate this prefix with particular site index. Site index is almost like a policy, so that when a large group of prefix fail due to like a power outage or network cut, you may, this particular physical event may impact large number of routes, and they may from IPv4, IPv6, and different SAFEs. Instead of individual ones announced to the ingress node, something being impacted, the egress router basically announce the physical availability index with like 0, for example, with a site index. So the ingress router, the receiving router, when they receive that, they will basically update the policy for all the prefixes associated with this particular site ID. And thanks, Sue, for helping me to revise that text to make it more clear on the ingress node is really applying the policy so that other next hop can be chosen for the same prefix. So there's a flag there. When the prefix announced it, it's really for association of the prefix with the site ID. When the loopback address announcing it is really to reflect the actual value, which impact all the prefixes associated with the site ID. There are quite a few mailing list suggestions asking to add another index for the service delay prediction. Originally, we only have one prediction. Basically, it's an absolute number, an integer, to represent potential delay. So the implementation is have a flag to indicate that delay can be actual value. So when this flag is set to 0, that's actually the raw, they call raw delay or raw delay prediction. And they will use the delay time defined in RFC 5905. So there are still some open issues in the GitHub. I think now we have 7 open issues, and there are some open issues asking for adding the capability for individual service instances, like say particular service require large amount of memory, or other services may require some kind of capability. They want to add that, so that is open. There's also could be the raw selection to avoid the churn of the raw selection. Like we may one prefix, like is really the anycast prefix, can be attached to multiple edge routers, and they may send out different pass metadata pass attributes, and we have to add this description to make sure the route doesn't churn so much so quickly. It has to have a filter there. And we think by going through this this standard BGP route selection process with policy plus router from routes, we think this problem can be addressed. And there's a section on how the metadata influence the decision process. So this whole section was added due to many comments on the mailing list on how can ingress node do, what can ingress node do with all those information. So that section was added, references customer BGP decision process and how to integrate all those metadata information together with the overall BGP decision process. And that can be implementation detail. We're just asking the working group, maybe that whole section can be moved to appendix instead of in the spec. So welcome your opinion to the mailing list or telling me offhand, either way is fine. So next step, we'll close all the open issues and we're asking for early allocation.
So we'd appreciate anyone, if you have interest in this topic, to take a look at the questions. If you want to make comments directly to GitHub, you can always ask for an ID. Hearing nothing, we'll go on. Keaton, go ahead.
Hello, Ketan Talaulikar, Cisco. So actually, this is a question for the chairs, perhaps. This work at some point was related to CATS working group. Any update on what's happened there?
So this work actually predates CATS, which is one of the things that makes this sort of interesting. So there is overlap. We did discuss that at the prior IETF. We did not come to any specific conclusion that the work was inappropriate to continue in IDR since we'd already charted it before CATS. What I would suggest is being the fact that CATS now exists, we certainly want to make sure that they're aware of the work. And that said, this is not specifically solving exactly the use case that CATS had. This is a standalone use case that has overlap. So it's, I suspect, this is chair's discussion, not necessarily something we would be inclined to say it's, if it's out of charter for CATS, that it should not continue here.
I have a question for chairs. So this is for asking an allocation for the metadata pass attribute. Obviously, that will be needed by CATS as well. So in the future, CATS say, I want the pass attribute. Is that come to IDR to get approval, or they can create a new one?
My understanding is that path attributes and BGP mechanisms come to the IDR working group.
So nevertheless, it will be
They would need to
standardizing.
come back. What we argued with Andrew, who's no longer our AD, was that this was a solution which was a mechanism. However, CATS does their architecture great. This is a mechanism that has immediate tactical, that means something that's deployable situation. And hearing that there are two implementations, it sounds like we made the right call. So Keaton, I think it was a very practical, tactical thing. There are people who want to implement it. It came ahead of CATS, and it's dealing with mechanisms, and mechanisms would have to come back here anyway. So given that, if you're interested, please make comments on this spec.
Okay.
Thank you.
Okay, so my second question, kind of related to first, this is called a metadata attribute. And it's a bit loose or open what goes into it now or what would go into it in the future. Is there, is this intended to be like a BGP attribute in which we can put anything and everything in it? Like, what kind of information is okay to be put in it and what kind of information is not okay to be put in it?
I think that has to come to IDR to discuss, right? If there's anything new to be put under this pass attribute, they have to have a draft, right?
Yes.
Okay.
And Ketan, I think to partially address your question back to the first one, Now, again, this was pre-cats. The use cases that this, yes?
So I think my question was different. I mean, if I
understand where
want
you're going.
to, yeah, if I want to just tomorrow, if I want to just put any attribute, any information to be sent, is this the attribute since it's called metadata? Is this the attribute where I can stuff it in?
I'm not going to get
Because
hung up
this
on.
yeah, I mean, at least it would be good to have an high level prop scope or like what's the purpose of this attribute and what kind of information it could carry in it.
Right.
That would be helpful. Thank you.
And that's why I'm saying this is relevant to your first point. We're not holding up this work until CATS figures out what they're doing. As of last IETF, we haven't really had conversations since this IETF. CATS was still figuring out exactly what they wanted to do, whereas this actually is making specific forward progress. If it is the case that CATS applications cleanly fit into here, we're hoping that, just like everything else in BGP, we'll cleanly reuse existing attributes and extend them. If you think that there's something in the structure of this document that prohibits that or makes it difficult, that is absolutely important as part of the review.
Can I say a clarifying?
And if it's the case that it is not a clean fit, we're very likely to see a distinct path attribute come into being for CATS purposes.
Yeah. So I just want to clarify that my second question was completely unrelated to CATS. This was more of a BGP question. It's useful to have at least some idea of what kind of stuff can go into something called as a metadata attribute.
That's a fair criticism. And if you have a naming suggestion, we ran into this for like next top capability. People are very hung up over the fact that word capability is there and think it's very static, whereas that's not the functionality. Very similarly here, this is not meant to be the one metadata to rule them all. So if you happen to think that changing the name to reflect a better scoping for this is appropriate, I'm sure the authors would appreciate suggestions.
Thank you. Thank you very much. Okay.
John, you've removed yourself from the queue. Did you want to go with?
Yeah, my points were largely captured by you and Ketan, but I'll just briefly repeat, which is number one, Linda, you had said, oh, well, CATS is obviously going to need this. And right, as far as I know, that is not obvious, at least formally speaking, although some people think CATS should do it that way. And then number two, I couldn't agree more with the sort of underlying point that Ketan, or that I think that Ketan was making, which is that without some kind of clear applicability and architectural principles for the usage of this thing, A, we're going to have problems, and then B, practically speaking, I'm going to have problems moving it through the IESG. Thanks.
Thank you.
Judd, I missed some of it. You're going to have problems approving it or problems with the name?
No, it's not a naming thing. I haven't reviewed the document yet, so maybe it's just great. But the gist of Ketan's question was essentially, is there some kind of guidance within this document that lets me know when it's appropriate to use it and when it isn't appropriate to use it? As long as reading the document lets me answer that question, it's all good. You can call it Randy.
Oh, okay.
You can call it anything you want.
Randy Bush.
Okay.
Excuse me, Randy. I didn't mean to have any negative comment on your name.
You have my consent.
So, Ketan, if you have some comments on whether the use is there or not, please help and make suggestions. Thank you, Ketan, for the active interaction.
Yeah, I will review the draft, the latest version, and specifically on that part, I'll pass comments on the list.
So can I start now?
Yes.
Hello, everyone. I'm Yu Jiagao from Beijing Zhongguancun Laboratory, and the presentation and the topic of the presentation today is about the packet content filter for BGP flow spec. And firstly, I will introduce some background about the DDoS attack trend. And the first one is it has more frequent. And in the first 6 months of 2023, there are 7.9 million DDoS attacks happens. This represents a significant increase of 31% compared to the same period in the previous years. And the second trend is about the hypervolumetric. And in last year, the largest DDoS attacks are recorded with 201 million requests per second. This attack did not just break the previous year's record, being nearly 8 times larger than the largest attack observed in 2022. And attack traffic is increasing, but the cleaning centers are costly to build. So we need to increase the filtering capability of the router to reduce the pressure in the cleaning center. And there are 2 techniques can be used in the router. The first one is ACL, but the ACL is challenging due to the need of manual configuration, and it will resulting in slow response time and the high risk of negative impact on business operations. So the next technique is the BGP flow spec. I think it's a better one because it enables the distribution of traffic filter policies such as traffic filters and actions via BGP protocol. It can be used to rapid spread filtering rules to mitigate DDoS attacks. The flexibility of BGP flow spec makes it as an effective DDoS defense technology to responding to the evolving security threats. Although BGP flow spec can provide the ability to filter traffic through untempos in predefined fields such as IP protocol, IP prefix, and port numbers and something else, but it still cannot filter traffic well in the face of some types of volumetric DDoS. As we can see in the picture, is an example which in the real operation network. It's ACK flood capture bombing attack, and it is characterized by a large packet, and the destination port is 443. The packet payload content has a fixed characterized, and in the picture, as we can see, it's all zeros. But for this kind of attack, the existing flow spec is unable to effectively to filter, and it can only be diverted, cleaned, and injected back by cleaning centers. So it's necessary to add a new flow spec filters for traffic with constant packet content, and to making this work, we're doing some surveys and have 2 insights about that. The first one is the latest enhancements in IP router forwarding planned filter implementations can support matching at any location within the packet header or content. This capability allows for the precise matching of attack traffic signatures and can be combined with traditional tempo filtering criteria to effectively mitigate DDoS attacks and minimize the false positives. So the device in the real network can support this kind of filter. And the next insight is we found there has been an existing draft before which have a similar topic. The latest update of this draft is in 2021, and they don't update for a long time. So contact to the author of this draft, and he told me he's not interested in this topic anymore. But I think it's an important thing because of the new trend of the DDoS attack. So we hope to continue to do this work, and maybe we can update based on the recently change of the attacks. So the most difference between our draft and the existing draft is there are two differences. The first one is we make some more router-friendly changes, and the second one is we will give continual adaptations with FSV2. And here is the packet content filter we propose in this draft. It has a similar encoding of the filters in FSV1, but the value contains 4 parts. The first one is offset type. It contains IP header data with TCP or UDP. Through this way, we can determine where is the started location of the offsites. And the second value is offset value. The third is content length. The fourth is the content value. If anybody interested in this, you can read it in our draft. And we also give some examples about how to use this filter. And as we can see in the picture, it's a use case about how to use this filter. There is a data center in backbone network suffered an ACK flood attacked with many packets containing identical content characteristics, and the cleaning device can generate flowback filter rules based on the attention information and send the flowback instructions to the routers, and routers can filter the traffic before the cleaning center. So this flowback filter can significantly reduce the cleaning center's overhead. In this draft, we have designed the filter only for FSV1, and we are welcoming any suggestions for further modifications. And in the future work, we will try to combine the packet content filter into FSV2, and we are looking forward to join the design team. That's all of my presentation. Thank you so much.
So first of all, thanks for the presentation. This was good. I talked with Sue, and we'll flash the slides from IETF 110 covering the prior presentation just to give additional context to the working group. But that work stalled out for 2 reasons. Number one, everything like that work had been gated on FlowSpec v2, and as you've heard, we haven't been able to get it started again until this year. So that's one of the reasons it went cold. The second one, as you say, the authors themselves have moved on to other things, but this is important, valuable work, so we're thrilled that it's being taken up again. And hopefully you're looking, as we discussed on Sunday, to have collaboration. This is definitely something we expect will be interesting to the producers of DDoS detection software, things like Arbor Networks, Deep Field, etc.
Thank you.
Thank you for the excellent presentation. Congratulations on making your first IDR presentation.
Thank you so much. I think that the people in IETF are nice and kindly, and I hope to thank Jeff and Sue. They gave me a lot of suggestions and encourage. Thank you so much.
So you can stay up if you like, but we're going to go a brief review over the existing draft Cora, and there's significant overlap, so that's not going to be a long presentation. Oh, sorry, please. You may sit if you like. Thank you. And we're presenting from Mac Preview. So these are the meeting material slides from IETF 110. Let's see if I can get this properly maximized. But again, I'm not going to spend a huge amount of time here because it thankfully has been covered very well. So as you see, this was several years ago. This problem is actually very important. Anybody who's worked in distributed denial of service software and tooling knows that this is a challenging thing and that it's actually very interesting to implement at scale. Some of the people that are producing DDoS tools make much of their living out of the fact that this is hard and it's very hard to make at scale. So I'm not going to go through the background and motivations. Yuzha was very good about that. Again, the slides are still in the 110 proceedings. And it's a very similar type of problem. Yuzha covered this very well. The one thing that I would add to her good presentation is that one of the main challenges any of these firewalls that do position-based detection have is deciding what is the start of the thing you're looking at. Are you looking at the start of the layer 2 frame? Are you looking at the start of a layer 3 frame? How does this change when you have tunneling involved? For example, IPGRE is a tunnel that the real payload you're trying to mitigate is hiding behind that. And active attackers make an effort to hide their traffic by changing stuff in variable portions of the packet. And in many cases, there's a desire to do the mitigations based on the layer 7 payload. An excellent example for that is things like DNS, where you want to look for some portions of subdomains. And we'll get into some cases where Yuzha's use cases are slightly different than the original authors. Again, this is mostly the same. The thing that's very slightly different is that layer 4 offset matching, it was one of the ideas here. I would encourage the working group to think about as we start looking at these features, what type of offsets we'll be looking for, and especially those of you who have implementations of this type of filtering, to offer advice as to what your implementations are capable of. But once you've actually decided where you're going to start looking at it, this becomes the second portion of the problem. Again, a place where the proposals differ slightly. Matching on pattern by bit string is a very common thing for each of these implementations. And this is extremely handy for things like matching out of PDUs. So she gave the example of matching TCP-X. This is at a known part of the frame and makes it very easy to detect using a bit pattern. Trying to do it for anything besides a bit pattern mask becomes very difficult without this feature. So this is probably a very core thing we're looking for. The second pattern here, which is not part of Yuzha's current proposal, it's worth the working group taking a look at, is what do you do about things that are byte strings of some form? And I'm going to stick to the DNS example because it's sort of easy, despite the fact that DNS encoding is actually very, very complicated. How do you match things like strings within the packet? I'm aware of use cases for matching domain names occurring in DNS, matching things inside of SMTP start messages, especially for TLS. The challenge that happens there is simple byte matching is a thing that you can do, obviously, but eventually start being driven towards more complicated mechanisms like regular expressions. And for any of you who've done work in regular expression engines, doing this at scale is very, very challenging. One of the things the working group should consider, and this is going to be true for a lot of our FlowSpec v2 related works, is that as we look at different levels of complexity for filtering, some of these things are likely to be optional parameters that can be done on some implementations, but maybe not others. And we want to learn how we can enable FlowSpec style filtering when there's inconsistent implementation across the deployment. This is going to be very important for making the protocol flexible, and it's also going to be very important for us to allow for the features to be able to grow. And I think, aside from the example, those are the main details that are relevant from the prior presentation. And I think Sue will have comments about how this goes into the chartered FlowSpec 2 work.
So again, this is looking at new filters, and that will be team 2 that I've announced earlier, but please give us feedback on new filters that we need to do. If you want to give us feedback on new actions, you'll find that. I'll announce all of this out later today and join the teams. I will announce out the first meeting for each of these teams. Any questions on all of this new fun work? Any other issues to bring up? Okay, if you ever want to shepherd a draft, shepherd or review a draft, should have said both, let the IDR chairs know we always want to have new people do reviews. Thank you again and have a good trip home.
We do the review as part of the Shepherd activity. AD will do the same type of review as well. The features that we're looking for when we're ready to early allocation,